right. What's going on?
All right, sorry about that delayed start there. This is the last enrichment problem of the week, okay? And I've been, towards the end of office hours yesterday, I gave you guys a hint, and Emmett suggested that we should draw lines connecting the centers of the circles together, like I have drawn right now, and thereby revealing we have, in fact, a triangle here. What do you guys notice about this triangle? Are there, do we know any other things about this triangle that we formed? Like, what are the dimensions here, for example?
We know that, like, the lines that, like, connect, like, halfway, like, are the radius, like, 1 and 2 and 3, but, like, you have to, like, add them together because they're, like, connecting.
That's right. So what's the length of the segment here, then?
This would be that we'll call that X. So unless we do not, no, it's one.
It's 3.
Say 1.
No, Sasha got it right. It is 3, right? Because this guy, yeah, because it's this segment, that radius is 1, right?
Oh, that one's 2.
Yeah,
I see.
So therefore, what about this segment here?
That's 4.
4.
That
it's
is
a 3,
4.
4, 5 triangle.
That's right. This is a 4, 5 triangle. This segment there, okay, is 5. So immediately, okay, we recognize this. Wait, is this triangle a right triangle?
Yeah.
Yeah.
It certainly is. This is a right triangle. Okay, that will help immensely. So our goal is to figure out what is the area of that shaded region there. Any suggestions on what we can do to find out what that is now that we've established this is a 3, 4, 5 triangle?
Well, we could find the area of the triangle and then subtract the area of the sectors.
I love that. So if I'm going to draw another triangle over here. Right, so this is 3, this is 4, and this is 5. So therefore, the area of this thing is, again, 1/2 base times height, right? So what would that be?
6.
That's just 6. That's right. So the area of the triangle is 6. So the overall area of the triangle is 6, okay? How on earth are we going to be able to find the area of the sectors?
Well, we need to find the angles, like, of each. And
We need to be able to find the area of the triangles, right? Whoops.
No, the sector.
The sector.
No.
But how are we going to be able to find the area of the sector, though?
Well, we need to find each angle of like the triangle.
We need to find the area of the triangle.
No, we need to find each angle of the triangle.
We have to find the angle of the triangle. I do agree with that. Do you guys agree with that?
Yeah, I agree.
Okay. How are we going to be able to find the angle of the triangle?
Well, we already have 90.
Yeah, have one of them. I do agree. So this is right angle. Okay. How do we get the other two? How do we get angle C and how do we get angle B? I know this is A. This is
sine and cosine.
B. We're going to use the things that we've learned during remote learning, which is, again, sine, cosine, tangent, right? So C, okay? So let's say if I wanted to find out what angle C was, okay? Again, my objective now, what is angle C equal to? What am I going to do?
You're going to do cosine of 90.
No. So let's say
cosine of B.
So cosine of C. That's right. That's the angle that we're looking for, right? So cosine of C is equal to what?
Cosine of C would be
3 over 5.
Not 3. Should be 4.
You have to have hypotenuse over
right.
Or adjacent over hypotenuse. Yeah.
That's right. That's right. So it's adjacent over hypotenuse. So cosine of C is equal to 4 over 5. All right. So cosine C is equal to 4 over 5. Okay. What do we do to get C, like to undo the cosine? There was something that we did.
You invert it.
We invert it.
Cosine -1 thingy. Yeah.
That's right. And the name for this was arc cosine. Remember that, guys?
Yeah.
Yeah.
Right? So C is equal to arc cosine of 4/5. So arc cosine of 4/5. So now we can find out what C is. Okay, we got to go to our calculator. So I'm going to jump over to my calculator here, and you should too.
36.86989765.
Okay. 36 point, say that again.
36.86989765.
Okay.
Just
So
try-
I'm gonna leave it like this. I'm gonna say like it's approximately. Whoops. I want to say that this is approximately. Sorry. I want to say that this is approximately 36.87. I'm just gonna round to like 2 decimal places. Okay. All right. So that's angle C. So therefore, what's angle B then?
take
Set
90
that to 90.
at yeah.
Yeah, we're gonna subtract this from 90. That's all it is. Sasha, you have the calculator handy. What is that?
54. Oh wait, sorry.
53.13.
minus- Yeah, that. Sorry, I forgot the decimal point.
No problem. All right, so angle B is 53.13. All right. I'm gonna get rid of this and try to make things a little neater. So that's what I have right now. I have angle B, I have angle C, and I also have angle A. So Emmett described a strategy for us a moment ago, and he said, well, if we find out the areas of the sector and then subtract it from the area of the triangle, we will then be left over with that that portion that we are trying to look for, right? So how do we find the area of the sector? Let's say for sector C. Sector C.
You set up the proportion thing? Like the
You can.
ratio?
You can certainly set a proportion. If you guys want to approach it that way, we can. But there's also a formula, right? I'm just going to remind you of what that is. It just comes in handy, right? So it's 1/2 beta. Actually, there were 2 formulas, right? So there was 1/2 beta pi over 180 times r squared, right? Where theta is in what measure?
In degrees.
Theta is in degree. And then there was another formula, which is 1/2 beta times r squared, where beta is in
Radians.
Radian.
Okay. So just bear that, keep that in mind, okay, if ever you are problem solving. But yes, certainly setting a proportion will get you to the same place. What do you guys want to do? You guys want to set a proportion, or you guys want to use the formula here?
Use the formula.
You want to use the formula? You guys all want to use the formula? Yeah?
Sure.
Okay.
Yeah.
So sector, so sector C, okay, will equal to 1/2. So I have 36.87 pi times 180 divided by 180 times r squared. What's the radius for circle C?
3.
It was
It's
3.
Wait,
Okay. So that's the area for sector C.
how do we
Sasha?
know it's 3?
Say that again. I'm sorry.
How do we know it's 3?
Because it was
Because of the
given.
circle. The circle of the radius. Yeah, exactly.
Mhm.
Circle C has a radius of 3.
Okay.
Alright.
Sasha, if you can, because you have the calculator handy, can
Yeah.
you do the computation?
do I do pi or like 3.14?
Pi.
Yeah.
But pi, but you can write it. Yeah.
Mhm.
And do I put like, and then times 9 because 3 squared?
Yep.
5.791526057.
5.791.
Oh, I forgot to sorry, I forgot to multiply that by 1/2. So 1/2. Sorry.
No problem.
Um, 2.8957630028.
Okay, so 2.8957 you said, right?
Yeah.
Yeah,
So
2
it's approximately 2.9 then. 2.90. Okay.
Mhm.
Okay. I'm gonna round to 2 decimal places, so it's approximately 2.90. And then we're going to do the same thing. So sector B. Okay. So again, it's the same idea, right? So we're going to do 53.13 pi over 180, and then times r, the radius for circle B. What was that again?
2.
2.
So it's just 2 squared. And then let's figure out what that is.
I got 1.854586863.
1.8154.
854.
854.
1.85458686.
Okay, so it's approximately 1.85. And lastly, for sector A, right?
It's 1/2. It's 1/2 times one pi over 2 times 1.
Pi over 2 times 1 squared. That's right.
Wait, we don't put in the 90 degrees.
So
Because 90 over 180 is 1/2, and we have
Yeah.
pi on top. So
that's right. Yep.
Got it. Um, 0.7853981634.
0.78. What was the last number? What was this third number?
53.
53. So it's 0.79 approximately. Okay. So we have these 3 sectors, and then the last thing that we're going to do is we're going to add them up and subtract it from 6. So the area of the shaded, is simply 6 minus, we're going to account for all of these, 2.9 minus 1.85 minus 0.79. And Sasha, you can tell us what that is when you get it.
0.46.
Say that again. 0.46.
0. Yeah.
Lovely. So that's our answer there. Were you guys able to get close to something like this when you guys tried it yesterday? Something to that effect. I'm sure you guys had the logic to get through. All right. So I'm going to stop recording. Thank you so much, guys, for participating.
No problem.